Hello guys, I am Karan. In this video, we are going to see how to solve the Striver SDE sheet. Okay, so basically nowadays people are using the Striver SDE sheet to crack their interview. Basically, this sheet is having the most asked questions by top companies, man companies, right? So basically, this sheet is having everything, every data structure. It is dealing with every main data structure from arrays to dynamic programming is price. Okay, so it is having 191 problem. We are going to see the first problem of this. The problem is from array. Okay, and the problem is set matrix zero. Whenever you get a problem, try to understand the problem first. The problem is set matrix zero. It is lead code 73rd problem. And the difficulty of the problem is medium. First, what they are saying is they are giving a matrix. Like here, we are passing a matrix to this function in this class, and they want to if an element is zero, set its entire own column to zero. For example, if this element is zero, right? So we have to make the whole respective row and respective column as zero. See, we have changed this, right? So basically, if there are zeros like this, we have to make the respective row and respective column as zero. Same applies to this zero as well. See, this will be the output. Okay. Why you may ask why this problem is in medium error? You can solve this problem in brute force approach itself, right? So the catch is a straightforward solution using O of M and space is probably a bad idea. We are not going to use many spaces. Okay. So a simple improvement uses O of M plus n space, but still not the best solution. They are asking us to give an optimal solution for this. Optimal solution means we have to use O of 1. O of 1 in the sense we are not going to add any extra spaces. Basically, same thing. Okay. Extra spaces in the sense we are not going to add any arrays or matrix extra. So I hope you all understood the problem. We can go to solve the problem. Before starting that, I have to mention something. A matrix is a 2D array. Matrix has two things. One is row and second one is column. What is row? So this thing you see here, one comma one comma one. This is called column. And this row, this first one, second one, and third one is called row. Okay. So you may get confused because everything is one here. So see this. This is row, right? First row, second row, third one. So sorry. So this is row. I mean the 1D array which is present in the 2D array is row. And apart from everything, this one, this is the first column, this is the second column, this is the third column. Okay. So how many rows we are having? How to calculate how many rows? How many rows is the number of elements in the column. This is the column, right? So we are having three elements. So we are having three rows. So how many elements we are having in a row wise? So for that, we have to see how many columns we are having. We are having one, two, three, four, four columns. So four elements of row we are having. Okay. So they have already given constraints also. We can get the matrix when it's obvious because we are dealing with a 2D array. So 2D array is having 1D array inside it. So the length of the 2D array is 3, right? So the number of, what is 3? 0, 3, 1. What is 0, 3, 1? It's a row. Column elements. Column elements means number of rows. Okay. So basically, the length of this matrix gives us the number of rows, and the length of the particular individual elements, 1D array, gives us number of uh, elements in a row. Or we can say number of columns. Okay. So uh, I hope you all know matrix. we use to represent matrix in M into N form. M into N in the sense M means row, N means column. Okay, row into column. So we can take the row and column separately and store it in a separate variable. Assigning and storing a data in a variable won't cost much space, so it will be 2 of 1 only. So matrix dot length, okay, it is giving the number of row we are having. Okay, so n gives 0 of length. Why 0 of length? Because we are taking the first element as a reference. We're just taking a matrix can't be empty, right? Matrix has to have at least uh, one D array in it. So that's why we are taking the first individual one D array and we are taking the length of it. And this is column. COLU number of column. This is number of row. Number of row. Okay. I hope it's clear. Then what we have to do? There are many approaches to solve this problem. Basically, if you are having, if you are doing brute force approach, what is brute force approach? First, you will check this one. No, it is not 0. So you will skip. Say you will see this. You will check until a 0 comes. So it is a 0. So you have to mark the entire row and entire row in the sense the respective row on the respective column as 0. If you mark this 1 1 1 1 as 0, so on the next iteration this element would be 0, right? So you can't you will do the same. You will make this and this as 0. So if you come here, you will make everything at last. If 10% in a matrix means at the last of the iteration, everything will become 0. So this whole matrix will become as a null matrix or 0 matrix. So it shouldn't be the case. So what we have to do? We can take some other number instead of 0. If we find the first 0 on the iteration, we will mark the entire row and entire column as something different instead of 0 and 1. Let's say we are marking the entire row. I mean, entire row in the sense the respective row and respective column as 2. So this one will become 2. And when we go to the next iteration, this will be 2. So we will skip. We will come here, come here, come here. So no 0 present. So then at the last, what we will do is we will put on another brute force approach in matrix loop where we will check if there is 2, we have to convert the 2 into 0. If it is 0, then no problem, skip. If it is 1, no problem, skip. Okay, so we can do uh, this kind of approach, but the issue is it will take more uh, time complexity. It may take O of n cube. Okay, so to reduce it, we can do one thing. We can either represent the whole row. We can mark the whole row. For example, on the iteration, it is 1, so skip, skip, skip. So the first 0 is here. So this 0 will have some matrix value, right? What is the value of this? 2 into 2. So what we will do is we will mark this 2 and 2, 2 into 2 separately somewhere. And once everything is done, after marking everything, like after iterating over everything, if some 0 occurs, means we will move the matrix value of the 0 somewhere. And after that, after everything, we will loop over each and every element. And if the element have the specific row or specific column, we will mark that row or that column as 0. So basically we have to um, initialize a separate array for maintaining this thing. So what it will do is it will give you the complexity O of m plus n, space complexity. To even reduce it, what we will do is we will optimize the solution. How to do that? Instead of creating a separate array for maintaining the marking the column and the row, we can use the row and the column of this matrix itself. How to do that? First, we have to check whether the first row and first column has any zero or not. If it is having zero or if it is not having zero, doesn't matter. We are just taking the note and we are saving it somewhere in a single element or single variable. Variable storing will definitely cost us O of 1. Okay, so once it is done, we are looping over other elements. Excluding this first row and first column, we are looping over this element. And if it is 0, we are marking the specific row and specific column header as something, as 0. Because if it is 0 means we have to mark it this also to 0, right? So we are marking it as 0. So then we will iterate over the other things. If there is no 0, fine. So we will again iterate over the same elements. We will check whether the respective header is having 0. Yeah, it is having 0, right? So it will be 0. So we will mark this as 0. So here we are checking this one is the one is 0, right? It becomes 0. It becomes 0. So we will change this one also 0. For checking this one, this is already 1. This is already 1. So it will remain constant, same, no change. So likewise, we can change everything. Okay, this is how we are going to change. If the first row is not having any 0, so we don't need to change anything. So we can do we can put it, let it be. For example, if this value is already 0, we have taken the note somewhere, right, in the variable. So we will at the last iteration we will check whether this first row and first column had any 0 or not. If it had a 0, we will convert the whole row and the whole column as 0. It may be confusing for you if you just hear it from your ear. So now it's time for you to see it visually. First, I'm checking whether the first row and first column having 0 or not, and I'm saving the value somewhere. So for saving, I'm creating a boolean variable. First row, we can use camel case. First row, default value is false, and again boolean first column, first call equal to false, default value. Okay, so typo, my mistake, sorry for that. Once it's done, we can iterate over the first row and we have to check whether it is really having 0 or not. For I is equal to 0, I is which row gives the element. I mean, we are iterating over this element column, right? We are iterating over the column element. We are iterating over the columns. So which will give us the columns is a row element. Right or wrong? We have to see this 111. Where is 111? Here is 111. So we have to use this n. Okay, so n I plus plus. Okay, so if I'm checking matrix, if matrix of first row, the element of the, I mean, we used to represent the matrix as row into column. This is first row, right? So first row in programming language we use 0 for representing the first element, and here I'm using I. So it will give 1 1. Oh, sorry. It will take the first element, this 111, and it will iterate over this 3 times. So it will give us 111. And I'm checking whether it is having 0 or not. If it is 0, we are changing first row variable to true. Okay. So we shouldn't forget to put this semicolon. Once done, we are doing the same for column. You can use any iterating variable here. It is not mandatory to use I and all. So for my convenience, I'm using I. So matrix of I of 0 equal to 0. First column, first call equal to true. I hope it's clear. Okay. So this two for functions, what it is doing, this two iteration function, what it is doing is it is iterating over the column. Oh, we used to call this as row, this as column. So if you iterate over this, we used to call, we are iterating over the column. If you are iterating over like this, we used to call iterating over the row. So we are iterating over the row and we are checking the row is having any zero or not. If it is having zero, we are marking it somewhere. So this initialization will take us only O of 1. This will give us O of n only. Okay. This will also give O of n because we are using only one for loop inside. Then what we have to do? We have to iterate over the other elements. O 0, 1, 1, 1, excluding the first row and first column. How to do that? I equal to 1. We have to, we are going, I mean, we have to determine whether we are going like this or like this. Row wise or column wise, we have to determine. I'm going row wise itself. So basically, how many columns we are having? 1, 2, 3. So it's better to go row wise. So I plus plus, and for int j equal to 1, we are using 1 because we already took the first element as the row header and column header n I j plus plus. Okay, so here we are checking whether the matrix of I of j, whether the matrix I of j is 0. If it is 0, we are marking the specific header. If it is 0, we are marking the specific header is, if it is 0, we have to mark the specific header, right? The header row is, the row number of the header is 0. So 0 of j equal to reassigning it as 0, and matrix of I of 0 equal to 0. You may get a little confusion here. So let's say I found a 0 here. So I have to change this one and this one to 0 for my reference in the future. So for this, what is the matrix value for this one? A row into column. First row, second column. 1 into 2. In mathematics, we will write as 1 into 2. But in programming, we used to write 0 into 1, right? So 0, that's why I have put 0 for 0 here, because we don't know j value. This 0 value might be dynamic. The 0 may be here, 0 may be here for a different matrix. So that's why j. So for changing this, what we have, what is the matrix value for this? 1 into 0, right? So that's why I have initialized 0 here, and I mean the 0 can be here also, but the first row is 0 always. Once it is done, we will make the header as 0. Then what we have to do? We have to again iterate over the element 1 I greater than m I plus plus, iterating over all elements excluding the header j n. Oh, sorry, it's a typo, my mistake. I'm really sorry for that. You have to check whether your code is fine or not. So here I'm checking. What I have to check for the second time, whether while I'm iterating, I have to check whether the header. If one of the header is having 0, I have to mark the current position value to 0. So how to do that? Matrix of 0 of I equal to 0. or matrix of I, I mean not I, yeah, I only, here I have to put J equal to 0. If either one condition met, we have to change the current value I of J to 0. Okay. If we do that, remaining elements would also become 0. If we leave the code like that, it will work. But we don't know the header thing, right? So see the second example, the header itself having 0. So in that case, we have to make the changes for the headers also. So for that, you have to check if first column. I'm checking if the first column is having first column or first row. You can do anything. First row. If the first row is having, uh, if when it will become true, if either one of the value is 0 means it will return as true. So basically, I'm checking if it is true, then iterate over the respective elements. Int I is equal to 0, I is equal to n only no n, I plus plus. Okay. Any one of it's 0 means I have to mark the entire thing. 0 of I, j, oh sorry, anything. I have initialized I here instead of j. That's completely your choice as 0. Same thing applies for first column also. You can change your iteration variable. That's completely your choice. I hope there is no typo. Here we have to change I of O. Okay, I of O in the sense I of 0. So I'm submitting a code. Let's see whether the code is yeah, some error occurs. Index 3 of length 3. Okay, I have to change it here. This thing M. Really sorry. So let's see whether it is passing or not. Yeah, the case is getting passed. So base case they have given two examples. So this base case got passed. Let me submit the code. Let's check whether it is passing or not. Yeah, it passed. So the runtime is 0 millisecond, and memory it is taking is 46%. So it is a optimal solution. Okay. So yeah, there are many optimal solutions like that. So if you see here, we have implemented a different kind of code. Is using tree set and all. So basically we are an array concept only. We can do that also, but it's a optimal solution. If they ask you this question in interview, you can use this code. They will definitely select you because the space complexity of the code is O of 1 and the time complexity of the code is what? See, O of n, O of n, O of n square, O of n square. So basically, the time complexity of the code is O of n square. Okay. So brute force it is giving us the value of O of n cube. But that's why we used to call this as optimal code. Okay. I hope you understood this question. I will see you in the next question. Pascal triangle. Thank you.